So section 2.2 is the beginning of our work on transformations of graphs. So on 2.2, we're just going to be talking about a vertical and horizontal shift. But before we do that, I want to be sure you have an idea and kind of understand what a parent function is. So a parent function is an original function that are, they're the functions that we use most often. And so they're called parent functions. And then what we do is we manipulate them, we transform them. But a parent graph is what they are in the very beginning. So here is an example of a parent graph. Let me pull it up here. And so these are parent functions. Here is a constant. We kind of know that's just a line that's either a horizontal line that has a slope of 0. But here is a parent function for a linear. Okay, this is just where we begin a simple y equals x linear equation. And then when we write something like, or we can write it as f of x equals x, since we're talking function now, we can write f of x equals x plus 2. Well, that's going to move that graph, or x minus 3, or 3x plus 7. When we start adding numbers, multiplying numbers, using operations with them, that then is going to shift and manipulate our graphs. So the parent functions are where they begin. So this would be, this V is an absolute value graph, and we use that quite a bit. Okay, remember anything that comes out of an absolute value is always a positive number, because this is really just the distance from 0. It's kind of the bigness of the number. It's not positive or negative. So anything coming out of here is going to be positive. So you can see on that graph, everything is above the x-axis, so it's not negative. Now that doesn't mean you can't manipulate it and move it down into a negative area on the graph, but the parent function is here. We won't do right now much with the greatest integer, but you can still see what that is. We work a lot with the quadratics. This is your parabola. Okay, this is just if you were to graph f of x equals x squared or y equals x squared, this is what it would look like. If we just do a table graph, here's a cubic equation in x to the third, kind of like a sideways. I kind of call it the chair graph because it kind of looks like a chair. The square root. Okay, here's what a square root. This is the parent function, how it begins before we manipulate it. Cubed root, we won't do much with the cubed root, but you can still look at it. Exponential is here, and logarithmic is here, and we'll get to those later in chapter 6 is where we really talk a lot about the exponential and logarithm. Okay, so we'll kind of get into these graphs here a little bit later. We won't do much any of the trigonometry right now. But so focused mainly on our linear, absolute value, quadratic, some cubic, and square root right now. That's kind of what we're going to work with on the parent functions. We're going to take those and we're going to manipulate them. So I want you to be able to recognize and say, well, I begin with an absolute value function, and then I shifted it like this. So you need to be sure that you can name what those are. And the quadratic is also called a parabola. I would like you to use the term quadratic because that's the correct math language to use for it, but it is also a parabola. So, we can interchange those words, but when you describe it, I'd like you to use the word quadratic. All right, so this was put in the chapter 2 review folder for you if you need that. All right, so back to our notes. I'm going to do a little bit different here. I'm going to kind of talk about things. I'm also going to go through a PowerPoint with some of this information. But I want to begin with, let's start talking first of all about a vertical shift of a graph. All right, so when we talk about a vertical shift, so vertical is going to be going up and down. So that's really going to affect our y values. We're shifting them up or we're shifting them down. These are really quite simple. It's just moving a graph up or down. That's it. So what we use for that is whatever our function is, whether it's absolute value, quadratic, whatever it is, plus or minus c. This c is a constant number, and that's the shift. It's either going to go up or it's going to go down. And that's all it is. So for example, if I have a graph, let's do a quadratic here. Now, mine's the sketch. Keep that in mind. This is not an exact graph. It's a sketch. So I have this graph, and I want to shift it. Let's say I want you to shift that to let's see, y equals f of x minus 2. All right, so this is saying I'm going to go down 2. So all I do is go to my graph, and I go down, I'll make this a dotted, go down 2, and this is where this goes down to. So it'd be something like that. We just shifted it down 2. Okay. And so if this were a plus 1, then it would shift this whole thing up 1. Now there is a difference between sketching a graph and graphing. And a lot of these are going to be sketched, all right? So that means you're doing it by hand. It's not exact, but some of them will be graphed. And if it is graphed, then you need, if I do say graph this, then that means you need to use an XY table, all right? So we'll talk about that a little bit later, but there is a difference between sketching and graphing. All right, so let's try this one. Let's take an absolute value. So here's our absolute value parent function. And let's do this. Let's do a y equals f of x plus 3. Okay, so what's that going to do? It's going to shift it up 3 because it's a plus 3. So 1, 2, 3, it's going to shift it up to there. And that would be our graph. That's all it is. So if you really, we're going to learn these in stages. We're going to do these different shifts in stages. So if you can just remember each part, because we're going to talk about each part and we're going to shift them in different sections, and just kind of keep those parts separate in your mind, it really helps. So always know whatever's on the end is going to be exactly what that shift is, up or down. All right, so let's talk about then a horizontal shift. Okay, so a horizontal shift, here is the equation for a horizontal shift. So whatever the function is, whether it be an absolute value, quadratic, cubic, whatever that is, all right? We're going to shift this. Now, this is what confuses students. This is the original formula for it, okay? So if I say to you, what if my constant is a positive 1? All right, so if my constant is 1, then what do I do there? Well, that means I put a 1 in for C. All right, so I'm going to come in here, I'm going to put in a 1 for C. Well, what is it that I'm really trying to shift here? I'm trying to shift it a positive 1. So a horizontal shift, this means I'm going to have the parentheses here, is going to be a right or left shift. I can put that right here, right or left. And I probably will put up here on this one just so you up or down. All right, so a right or left shift. Well, if I look at this, if it's a positive 1, would you agree I'm going to want to shift it 1 to the right? But, and that's correct, you do shift it 1 to the right. But it looks like when I put it in here, I'm saying move it 1 to the left. But what C is there is 1. It's just because this equation, the formula is a negative, but C is a positive 1. So this is going to be a shift 1 to the right. So let's say that my constant then is a negative 3. So if I put that constant in here for C, right here, it's going to be minus, and then C is a negative 3. Well, what happens here when we take a subtract a negative? It's the opposite of a negative, so that becomes a positive. So this becomes y equals f of x plus 3. But when I look here, what is it I want to shift? I want to go 3 to the left. However, when I look at this, it looks like I want to say 3 to the right, but it's not. It's 3 to the left. This is a 3 to the left because C is negative 3. Here, C is a positive 1, and we're shifting it whatever that constant is. So that's kind of tricky. So that's why when I look at these and I'm doing a horizontal shift, I'm always shifting it the opposite direction of whatever that sign is. That's the reason why. I don't do that here. This is totally different. This is exactly what it is, a shift up or down. This is going to be a shift the opposite of that operation. So let's say we have, let's do this one. Okay, let's take a look at that. So if I want to shift that, let's go ahead and do a square root. So here's a square root. Okay, that's the parent function of a square root. And we'll talk a little bit about when we know what these functions are. This is just the basic, wanting you to understand how to shift it, all right? So I'm just saying, here's the function right here. So what are we going to do here? If we have a -4, what are we going to do there? We're going to shift it the opposite direction. So we're going to take it and we're going to go 4 to the right. So 1, 2, 3, 4. We're going to start here. We're going to go 4 to the right. And it seems odd, right? But you have to remember, when you do the horizontal shift, which is always within the parentheses, you're going to do an opposite shift. So how about this one? Okay. So if we think about that, and let's go ahead and do an absolute value. Okay, so what's that one telling us to do? Opposite of that. So we're going to go 2 to the left. 1, 2, and that's where that graph is translated, shifted. Okay, so that's the main thing, is just remembering it's the opposite of this. So now you know how to do a vertical shift, straight up and down, vertical shift, whichever it says, and you know how to do a horizontal shift. Okay, and we've talked a little bit about what a parent function is. So you always begin that parent function like the pictures that I showed you, that you can look up into your chapter 2 review under pages. All right, so how about I'm going to bring this PowerPoint up and just ask you a couple questions on this here. Oop, that's not how I do it. All right, so take a look at this. Now, let me get this a little bit bigger for you. All right, so we're just going to kind of scroll through this real quick. This is kind of what we already talked about, doing our translations. All right, so let's take a look at this, and it says give the domain and range of this. So give the domain and range. Well, here's our parabola, okay, and they're telling you the shift on this, and this is kind of what I wanted you to see. So notice, our parabola is usually starting at 0, and then we're going to do our horizontal shift first. So this, we went 1 to the right, and then we went up 2. So how we write that is we -1 and then 2 up. Now this, when it says x squared, so x squared was the original parent function. And then we shifted it 1 to the right and then 2 up. Does that make sense? Now what is the domain of this? So if these arrows go on infinitely, correct? So we're going to go -infinity all the way to +infinity with parentheses. That's what we're going to put in interval notation. So right here, the domain is -infinity to +infinity. All right, so if you just take a quick look at this, what would the range be of this, starting from the bottom to the top? Well, it's a solid line, so we're going to have a bracket of 2. Remember, the range is your y values, 2, and then this goes up to +infinity. So here, our range goes from 2 with a bracket to +infinity, 2 to +infinity. All right, so let's take a look at the next one. Let's look at this cubic graph. So this part, remember, just starts at 0, 0. So we went 1 to the left and down 2 to get that. This is the starting vertex at 0, 0. We went 1 to the left and down 2. So our parent equation is y equals x to the 3rd. That's the cubic equation, right? It looks like a chair. That's cube. All right, so what do? We went 1 to the left, so we have to put a +1, and it's cubed, right? X cubed, we just put a +1, and then we took it and we went down 2, so -2. Now, what do you think that domain is of this graph? It's -infinity to +infinity. That's your x values. Now, what is the range? Which are your y values? Well, this continues to go all the way down, right? So this is going to be -infinity, and it goes up to +infinity. So it's exactly the same. Negative infinity to positive infinity is the range and the domain. They're exactly the same. All right, so let's take a look at this one. Well, we know this is the square root parent function. So we started here, and it looks like we went 2 to the right, and then we went down 3. So we start with our square root function of x, and then we show that we went 2 to the right, so we use the opposite sign, and then we went down 3. All right, so what is the domain of this? So where does this graph start with your x-axis? It starts at 2, and it's a filled-in circle, so that means it's a bracket. And then where does this go? This goes to, keep losing my arrow, this goes to positive infinity. So bracket 2 to positive infinity with a parenthesis. Okay, what is the range? Well, what's the lowest point of the y? Well, the lowest point of the y is -3. So we have a bracket, -3, and it will continually go up, 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 up. So our y values will continue to increase to a positive infinity as well. So here is, here's our, let's see here, find where we're at here. Here is our domain, 2 to positive infinity. This is the parent function. That's what it starts at, the parent function. And this is what the new one, it begins at -3 to positive infinity. All right. So I want you to take a look at this. I'm just going to go through just one part of this. I want you to take a look at this equation model and how we can add a shift to it. So this is the number of monthly Facebook users in millions from 2019 to 2017. So X is the number of years after, 2009 to 2017. X is the number of years after 2009. So if this asks you, remember we evaluate f of 2 and interpret that. That just means we're going to put a 2 in for x right here and find what that answer is. So when the x is 2, which would be 2 years after this. So if this year is the first, this is going to actually be 2011 if we start with 2009. So this is really saying, okay, well in 2 years, which would be 2011. What's the dollars going to be? So we put 2 in for x, and that would be 2 times 233. So what? 466 plus 200, $666 million in 2 years. That's a lot, isn't it? All right. So what I really want you to do is B. I want you to write an equation. I want you to write an equation that gives the number of monthly active Facebook users, y, which means I'm going to do y equals, in millions during the actual year x. So here the actual year x is 2009. So all we're saying is this is going to be a shift. And we're talking about an x. So tell me, do you think that shift is going to be horizontal or vertical? Well, if it deals with the x, it's going to be a horizontal shift. And it wants to know the number, where x is the number of years after 2009. So I want you to write an equation model for the years after 2009. So if I look, kind of just put some quick notes down here. So where x is the number of years after 2009, write an equation during the actual year x. So instead, put it in terms of y equals. So y equals. So all we're doing is we're going to look at this, and we're going to do this shift for the years after 2009. So that means our C, I'll just write that over here, C is going to equal 2009. And if it's after, that means 2010, 2011, 2012. So would you agree it's a positive shift? That's going to be a positive shift because it says after. That's the key word, after 2009. So it's a positive shift. So if I want to just put this into the equation, I'm going to have 233. Now, what's my shift going to look like? If it's a positive horizontal shift, we're going to put minus 2009 plus 200. And that's it. That's the equation for that. Now we could go back and say, okay, well, what about, and I think this said, so what when they have $1 billion, what would that be? Well, then we would just put $1 billion in right here, and we would solve this equation for x. But my focus right now is really just wanting you to be sure that you can write this type of an equation. with your modeling. All right, so that is section 2.2 with horizontal and vertical shifts. So good luck with that. Have a good one.